Hello everybody, getting ready to do lesson 9.9 for Algebra 1, Part 1, Part 2, Part 3 available here. Modeling relationships, quadratic equations, and functions. Here's our standard here. We have a Part 1 lesson here. Our classwork sheet is 30 points. And then we have a 2-point note-taking guide. Teachers, here's your bell work for today. We have a table, and we have a tell whether the data can be modeled by linear, function, exponential, or quadratic. So we need to know what kind of function this is. Give your students 5 minutes. They should be able to do this in 5 minutes. Okay, our solution for our bell work today. Data represents quadratic because the second differences are equal. The quadratic function, the length equals at squared, use 1 and 0.82. So we have this situation here. The equation is L equals 0.82 t squared. By using 2, when x equals 1, y equals 0.82. So that would be our quadratic for that. 1 when x equals 1, y equals 0.82 when x equals 2, etc. And then do we get a graph from that? There's our graph. And this would be a quadratic. This would be 1/2 of a parabola here. And that's a quadratic. The graph has a curve, so a quadratic function or an exponential function could model the data, but it is quadratic. And then here is the second differences are all the same here. Once you diagram this table here, you find out that the first differences and then the second differences are all 1.64 here. Okay, that's how you really tell. Okay, so modeling relationships, you study linear, exponential, and quadratics. You will compare representation these functions. So our notebook entry here's our 2-point notebook students. Sometimes you find it helpful to model a function with a graph even if you don't have enough information to write an equation to model the function. Sketching a graph based on a description of a situation can help you understand the situation and identify key features of the phenomena or the model. Okay, example 1, sketch a graph of a real-world situation, firefighting. A firefighting boat reaches a maximum height of 25 feet and travels horizontal distance 140 feet. What type of function should you use to represent the path of water? Sketch a graph of the path of water. Here's an example here of the path. Looks like a parabola, represents horizontal distance in feet, and let y represent the y, the vertical distance there. In the context of a given situation, what do intercepts and maximum point represent? As a can on a boat, graph only has one x-intercept where the water reaches the surface or the ground. It starts over here on the boat, a little bit above the x-axis. Okay, maximum point of graph is where the water reaches its maximum height, about 70 feet. So we can use the vertex here of that parabola to model the height of the water. Using graph example 1, describe intervals in which the function is increasing, decreasing. Explain what the intervals mean in a given situation. And then 2, this is your students, a hot air balloon, blah, blah, blah. Read through it and do that on your own. We're going to do the guided practice now. So using graph in example 1, describe the intervals. Explain what the intervals mean. So the function is increasing as x increases from 0 to about 70, so about to here. It's increasing. And then the function is decreasing from 70 to about 140. So it's on the side there. Compare properties of two linears. So linear function 1 has an x-intercept 4. Y-intercept of -2. Linear function 2 includes the points in the table below. The slope of a linear equation indicates how rapidly a linear function is increasing or decreasing. The points 4, 0, and 0, -2 are on the graph of linear function 1, so its slope is 1/2 for linear function 1 here. So the table for linear function 2 shows that for each increase of 1 in value of x, there's an increase of 5. For each increase of 1, there's an increase of 5 here. 5, 5, 5, and 5. So its slope is 5 for 2. So linear function 2 is increasing more rapidly. Okay, I got to practice here. Students, pay attention. So you can do your independent practice here. Compare the rates of change in linear functions 4x plus 5 and 3 minus 4x. Okay, so our slope here is 4 for this one. For right here, we got a slope of 4. And then for this one here, we have a -4. So -4 will be the slope of this line here. So the second function is decreasing quicker. It's got a steeper slope than this function here, which has a slope of 3. This has a slope of -4. Then we got 13 and 15 for each increment here. So, and then this one has 1 and 5. This is y1, y2. So this is a difference of 4 here. Then this is a difference of 4 here. Okay, so that was lesson 9.9, part 1. If you need part 2, part 3, email me here. If you need worksheets and online tutoring, etc., email me there as well. Thank you very much.